So we've talked about optimizing our matrices, we've talked about things like backface culling and shader optimization tricks and other such things, but at the end of the day, when it comes to making your 3D games in GameMaker run better, it's hard to beat the simple fact that if you don't have to draw something in your 3D game in GameMaker, don't draw it. And that can take many different forms. Today I'm going to talk about the two aspects of that which I think will be applicable to most situations. So for the last time, hello all you crazy people out there. My name is Michael, I like wizards and dragons and making games, and let's talk about optimizing 3D games in GameMaker. So, this is the last one of the 3D optimization videos that I have planned. I won't say that I won't do any more ever, but this is just the last one that I have currently plans to do. So let's get into it. So I've made some changes to the 3D optimization demo. I have a lot of trees being drawn. I believe this is 1,000 trees. Yeah, tree count is 1,000 if I peek over here in the code. The other major change that I've made is that they are all being drawn individually. They are not being combined together, as you can probably infer by the dancing yellow bar in the that represents the draw event in the debug overlay. And also, as you can see in the upper right corner, I've got a secondary camera rendering, which is also not really helping performance matters much. But I've got a secondary camera rendering, and that is serving to give us an overview of the entire 3D world, not just tied to the player. So you can see when I'm in certain places, you can see my player cylinder walking around when I'm just in the right place to be seen by the 3D camera, by the overhead camera rather. And that camera is not following us around when I walk around. And the reason for that will become clear soon enough. First, standard disclaimer that I like to put at the beginning of every one of these videos. If you have not seen the earlier videos in this series, I recommend going and doing that. If you're not already moderately familiar with how 3D graphics work in GameMaker, I recommend going back and doing that. I've made many videos in the past on such matters. Some changes that I made from the last one, in addition to the main things that I described. I've commented out the code that combines all of these tree vertex buffers into one. So that's just commented out. The tree data array now has a texture, which honestly isn't all that important. It's got an X position, which is random, and a Y position, which is random. More or less what we had before, although I think the exact way that this data is stored was slightly differently before. In the draw event, because I'm recycling a bit of drawing code, I have moved the main world drawing stuff into a separate function, and all of the things such as setting the lighting uniforms and submitting the vertex buffers of various kinds, these all live in a separate draw all the stuff in the world function. I think the name explains what it does more or less. The 3D cameras are set outside of that function, so the 3D cameras aren't in the draw GUI event. Mostly this is the same, except after the stats that are being drawn in the upper left corner of the screen, we are creating a surface for the overhead camera. We're clearing the surface, setting the camera matrices so that we can look across the room with an overhead view across the map, and then drawing all the stuff in the world once again. And then we simply draw the overhead camera surface in the corner. That's odd. My Raspberry Pi did not want to turn on today for some reason, but it appears to be going now, and that's all that matters. So I'm going to run this on the Raspberry Pi. I'm not actually going to make super heavy use of that device today. Wait, before I do that, hang on, stop. Before I do that, let me cut the tree count down from 1,000 to 100, because I want this thing to not actually catch fire and explode right here on my desk. That would be a bit of an issue. Anyway, I'm not actually planning on making super heavy use of the Raspberry Pi today, because what I'm going to talk about is going to be more conceptual than anything else, more conceptual than the previous videos in this series. But just so that you can see how it's doing, this is how it's doing. It's not doing well. Let me close that, and let me switch my monitor input back to my regular Windows computer. So if I were to jump back over here to Windows, and let me actually make the text a little bit bigger so that you can see it better, you can see in the list of models that I have loading from files, we have the player, we have tree, loading from tree.d3d, we have tree_lod.d3d, and we have the Going Merry, which I was going to use in this video and then decided against it. If you want to play around with that pirate ship 3D model, go ahead. It's not very good, I made it myself. So if you've never seen the abbreviation LOD before when it comes to game dev, LOD stands for level of detail, and The reasoning is that if you're far away from an object, if your camera is far away from an object in 3D space, then it's going to appear smaller, because that's how perspective cameras work. Parallel lines converge on the horizon. And if you're far away from a 3D object, you don't need as much detail in it, because you won't be able to make out as much detail in it. And it makes sense, in order to save processing time, that for such things, you might want to draw a version of the 3D model with a lower level of detail. So if I were to open these up in Model Creator for GameMaker real quick, we will be able to see that tree.d3d is going to have, I want to say, about 380 triangles in it. This is the same one that I was using in the last optimization video. Let's get a zoomed in view of this thing. This is what it looks like. It has got 381 triangles in it. Meanwhile, the level of detail version of this tree that I built is going to be much simpler, and it's going to be, instead of having a lot of detail maybe in the branches, or at least a moderate amount of detail in the branches, it's just going to be basically a cone stacked on top of a cylinder. And this is only going to have 16 triangles in it, so that's about 1/20th, 1/24th of as many triangles as in the full-scale version. I know I've said on occasion that in general, you don't really have to worry about how many triangles are in a 3D model that you're trying to draw, but considering that, for example, the Raspberry Pi that I'm trying to run this on has a very, very weak GPU, if you're able to only get away with drawing 16 triangles per tree instead of 381, you definitely should consider doing it. So let me come over sideways to this draw all the stuff function, and I'm going to write a little bit of code, and I'm going to start by declaring a variable var dist to tree. So this is going to be the distance to the tree, the distance between the camera and the tree specifically. Up here at the top, I'm not actually using this for anything currently, but I am calculating the camera's to and from position, and that is going to, based on where the player is standing, and that's going to come in a little bit handy when it comes to figuring out where objects are relative to the camera. The camera's matrices are being set outside the script, as I mentioned before, but we are calculating the x2, y2, z2, and the from position, the to and the from position. So the distance of the tree is going to be point distance 3D. Point distance 3D is basically a GameMaker abstraction of the 3D distance formula. It is going to give us the distance between 2 points in space. X1, Y1, and Z1 is going to be the X from, Y from, and Z from. This is where the camera itself is located, and X2, Y2, Z2 is going to be data.x, which is the x coordinate of the tree, data.y, and 0, because the tree is always being drawn at z equals 0. So this is going to be the distance between the camera and the tree, and we can make use of this value. We can say, for example, if the distance to the tree is greater than 1,000, we're going to draw the LOD version of the tree, the low level of detail version of the tree, and that might look something like if dist to tree is less than, let's give it an arbitrary value of 1,000, then we will vertex submit VB underscore tree. Otherwise, if the distance of the tree is greater than 1,000, we will draw instead the level of detail version. And that's, in this case, that's going to be a little bit close. We're going to be seeing somewhat one might call pop-in. So if I stand here, if I stand around here in the middle of the room, you can see that the trees nearby, the trees close to the camera, are using their fully modeled selves, whereas the trees that are far away, or moderately far away even, almost as far away as the player, in this case, then they're going to be drawing their low level of detail model. And if I were to even rotate the camera so that the camera's a little bit farther away, you will see what one might call pop-in. If I back up away from the actual playing field, you can see that the trees are transitioning to their very simple 16 triangle versions of themselves, the low-level detail versions. And the purpose of the overhead camera is so that you can see this a little bit. You can see the transition happening regardless of where the player is actually standing. So if I rotate the camera, you can see in the overhead camera the trees being drawn as either their low level of detail or their regular level of detail versions. And you can see when I back up that, I guess I wasn't planning on using the Raspberry Pi that much in this video, but I guess I ended up doing that. You can see when I back up, the frame rate is going up when we're just drawing the simpler versions. Again, fewer triangles to process, fewer vertices to process.
Hey.
Whereas if I were to walk closer, the frame rate is going to go from 20, which is almost acceptable, and it's going to quickly drop down to 10, 9, single digits, 8, 9, not ideal. So let's see. I think I can kill that off now. So you can imagine from that demo that using a lower level of detail models is not a bad idea if you can get away with it. It is not uncommon on larger scale 3D video games to have multiple versions of the level of detail models. You might have the full scale version for the regular 3D model, and then you might have a level of detail model for the middle distance, which has most of the detail, but maybe some of the finer details are removed. It won't include some of the smaller triangles. And then you might have a far level of detail model, which, as this one is, it might basically, if your model is a tree, it might just be a cone propped up on a cylinder. And you can also do this with textures. You can also, if you have a larger texture for your close-up model, you might have a lower resolution texture for the far-away model so that you don't have to keep as much texture information in video memory. And really high-fidelity 3D video games might have even more than that. They might have 5 or 6 different levels of detail rather than just 1 or 2. In reality, I somewhat doubt that most people who are making 3D games in GameMaker are going to really have a need for multiple levels of detail. But you can say if the distance to tree is less than 1,000, else if the distance to tree is less than maybe 5,000 or something, you can draw a second level of detail and then else draw a third one, something like that. But I'm not going to do that. I'm just gonna move on. I will, though, go back to running this on Windows so that you can maybe see a little bit of a better transition than what you saw on the Raspberry Pi. So I'm going to say if distance to tree is less than 5,000, I'm going to scroll back over here and set tree count back to what it was at the beginning. And I'm going to run the game. This isn't really going to have an effect on the frame rate. There's not enough stuff in this scene. There's not enough triangles total in the scene to for this to really make a dent. But you can see I'm getting right now about 54, 51 frames per second about. You can see way off in the distance, way off out there. You can see that the trees do have a little bit less detail, although it's hard to notice. It's not really the sort of thing you would notice unless you were like squinting really hard at it. So in this case, a distance of 5,000 probably isn't a bad cutoff. And if I were to back up, and if we were to look at the overhead camera in the corner, you can see that as I get farther away, the trees are going to resolve to the lower level of detail model because from where the main camera is, I don't need as much detail, and you can still see it looks like a forest, but you really don't need to see all the detail in the individual contours of the tree branches and that sort of thing. And if I were to walk back up, you can see the trees are starting to appear again, and if I were to disappear the other way. And if I were to back up enough in this direction, you would see that, once again, the trees would start to lose detail in the opposite direction, like that. All right, that's level of detail. I haven't talked about vertex fog as an optimization trick. You may have seen vertex fog mentioned as an optimization trick, particularly when it comes to older like PS1 and 64 games. If you have fog implemented in your 3D shader, that's not itself optimization, but it can be used to hide things such as objects losing detail in the distance if everything is blending to the same color anyway. It can be a way to hide that transition so that you don't see the actual moment of pop-in, or at least it'll make it much harder to see the actual moment of pop-in. And then, of course, if something is farther away than the maximum fog distance, you can just not draw it entirely, and as long as it if the fog is the same color as the background, as the skybox or whatever, it may as well just not be there. Worth mentioning, I'm not going to be doing it in this video. So something else that comes up a lot, and something that I've been asked about a few times, is frustum culling. And frustum culling is the concept of if something is not within the camera's field of view, or more specifically, if something, and I don't know why I closed the game because I might as well just leave it open. If something is not within the cone of the camera, if something is not directly in front of the camera, don't draw it. And that is a subject that is deceptively more complicated than it sounds. Figuring out if a point or a 3D shape is within the frustum of the camera is a bit of an ordeal. Frustum culling is deceptively complicated. There's not just a nice, simple, neat equation that you can use to figure out if a point or an object is within the view cone of the camera. And Considering the GML is a unfortunately slow language, all the implementations that I've tried for proper free-stream calling have actually been more expensive to compute than just drawing everything. That probably isn't universally true. There probably are some situations where doing proper free-stream calling calculations in GameMaker will pay off, but generally speaking, I don't find it to be very useful. Now, with that said, there are still some things that you can do. There are some compromises that you can do I don't know if you would want to say emulate free-stream calling, but to at least get some of the benefits that free-stream calling gives you, and that it doesn't require you to draw everything if it's not in front of the camera. And that is going to be, in my case, this is what I do. And again, this will not work for all 3D objects, but in general, I find it to be useful. I am going to, let me just get rid of that commented out matrix set. I don't really need it anymore. Actually, you know what? Let me make a commit in source control. I haven't been doing that today. We're going to draw the level of detail models. And I'm going to define a few more variables. And the first one is going to be var dist. No, that's the last one. Var dir to tree. So the direction to the tree. And this is going to be similar to point distance 3D to the previous line. Instead of point distance 3D, I'm going to say point direction. And we're going to go x from, y from, data.x, data.y, data.x I said, data.y. Next, we're going to do another one, and this is going to be var dir to camera. That's also going to be point direction. This is going to be x from, why do I keep hitting D instead of x all of a sudden? X from, y from, and x2, y2. So the first one is going to be the angle of the tree relative to the camera, to the camera's position, and the second one is going to be the direction that the camera is actually pointing in. So it's going from its from position to its to position. And this is just a 2D angle. We are not looking at like 3D polar coordinates or anything. This is just, it's not taking camera pitch into account, just the direction, just the bearing, or the yaw if you're a fan of aviation. And if you want the difference in the angle between the tree and the camera, we can say var, let's call it direction difference is going to equal angle difference. Angle difference is a handy function that GameMaker has built in. It's just one of the math utilities, and it will compare two angles. We can say the first angle is going to be dir to tree, and the second angle is going to be dir to camera. And this is going to return a value between negative 180 and positive 180 in degrees. If a tree is right in front of the camera, then the angle difference is going to be very low, very close to 0, because the two angles are going to be similar between the camera's looking direction and the direction between the camera and the tree. And if a tree is way off to the side, then the difference in the angles is going to be very great. So our camera, as you may remember when we set this up, and I pretty much, where is it? Probably in the draw event. I pretty much set it to this like way back at the beginning of the 3D tutorial series and just left it there without changing it. The field of view is 60. Feel free to ignore the minus sign there. That's just there to bypass a quirk of GameMaker. So if the angle difference is greater than the field of view, then the tree really won't be visible to the camera, and we can safely just not draw it. So I can say if direction difference is, let's say, less than 60. Now, I should mention, angle difference can return a negative number, depending on whether the first angle is to the right or to the left of the second angle. You could say either, if you wanted to account for the negative, and direction difference is greater than negative 60. Or you could just take the absolute value of the angle difference, like this. So if the angle difference is negative, it'll just become positive. Up to you. Doesn't really matter. I'm going to take the absolute value because it's less code. We can say if the angle difference is less than 60, then do the drawing, otherwise don't do the drawing. And that is going to allow us to simply not draw trees that are not within the cone of the camera. Okay, so the game is running again. You can see that when I walk forward, trees that are outside the cone of the camera are disappearing. When I spin around, you can see the cone of trees appearing and disappearing, kind of like a lighthouse, which is actually a really cool effect. I like that. I kind of want to make a game based around that now. Like, just that. Alright, maybe I'm just weird. Anyway, you can see in the main 3D view that everything that is on screen is still being drawn. It's just the trees that are way off, not within view of the camera, that are not being drawn. So trees behind me are not being drawn, which is obviously helpful. Trees that are off to my side are not being drawn. When there's a couple instances when I just put the camera in the right place and like walk forward, you can actually see it disappearing, but that's very much an edge case, and it's hard to catch it on purpose. So you may notice that the cone that's being drawn is a little bit wider. Oh, here we go. Okay, so if I move the camera up, you can see the pop in. The cone that's being drawn is a little bit wider than the actual field of view of the camera. You can finagle that all you want. You can make it... I forget exactly off the top of my head what the field of view encompasses. I want to say it's like, if you have a field of view of 60, it'll be 30 degrees to the left, 30 degrees to the right, multiplied by like the aspect ratio, which is, in this case, 16:9. So I want to say if you were to say direction difference is less than 30, multiplied by 16 divided by 9, that would approximately make the angle that you're checking exactly the camera's field of view, although I'm not 100% sure. Regardless, that's not super important. Okay, we have narrowed the field of view a bit, and we do still have all the trees that are visible being drawn, so it's probably pretty close to what I typed out there, but again, I'm not 100% sure. This isn't perfect, especially when I do something like move the camera way up like this, or in the other direction way down like this. You can see some trees disappearing, maybe when they shouldn't. You can choose your own strategies for accounting for that. Something else you can do, instead of using the point direction function, which is probably the most straightforward way of doing this, is using the dot product, one of the dot product functions. I've used the dot product pretty extensively in shaders for purposes of lighting, but you can also use it in GML. That's another function that's part of GameMaker's math library. There exists a dot product function for both 2D and 3D, and you could use the dot product of the camera's from position and the tree's XYZ position, and you could use that to compare the two angles instead. But, and that will probably give you a more accurate result, but this is the kind of thing that I'm going to encourage you to play around with on your own. Okay, now lastly, just for fun, before I end the video, let me run this on the Raspberry Pi. If I go into the create event and... like, what would actually happen to my Raspberry Pi if I tried to run this with 1,000 trees being rendered twice? Would it run at, like, 3 frames per second, or would it just, like, completely crash? I don't think I want to find out. It probably wouldn't just crash outright, because it's not like that would cause it to, like, completely run out of system resources or anything. It would probably just run at, like, 2 or 3 frames per second, but even then, I don't think I want to find out. So, fortunately, this isn't really helping. If I were to completely point the camera away from the forest, we might actually see a double-digit frame rate, but unfortunately, even with this, the Raspberry Pi, and you can see the math is working with the field of view. You can see things disappearing when they go off screen, but unfortunately, this is simply not enough to get the game to run at any reasonable frame rate on the Raspberry Pi. So again, not all situations. This is not something that will work for all situations. It seems to be much more bound by the fragment shader than the vertex shader, because now all the trees are still being drawn, but they take up much less space on the screen, so there are fewer fragments to be rendered, and that seems to be very much more of a significant performance boost than simply just not drawing trees in the first place. Anyway, there we have it. That is I've done like fake shadows and fake outlines. Do I want to call this fake frustum crawling too? Should I just make a series of like faking effects in GameMaker? I don't know if it's actually a good idea for me to use terminology like that. It might like give people the impression that it doesn't actually work and that they shouldn't do it or something. Anyway, let's see. I'm going to make this a commit. That is going to be it for me in terms of 3D optimization videos, at least for the time being. Did I not save? All right, there it is. I will not mess with the tree count. For lack of better words, what do I actually want to call it? Alright, stuff outside the camera's field of view isn't drawn. So if you want the code for this, look for the GitHub repository down in the video description. This week's particular thing will be on the optimization drawing less stuff branch, although by the time this video is public, it'll probably be merged into master, along with all of the other things. I hope you got something out of this. I hope your 3D games in GameMaker are running slightly better than they were at the beginning of this series. It's doubtful that any given person with any given game is going to be able to make use of all of the things I've talked about in this series, but hopefully at least a couple of them have given you a nice performance boost. There was a day many years ago when a vast majority of people who tried to use GameMaker for 3D, including myself, basically did it by drawing a bunch of quads as inefficiently as possible, and let's just say that those days are long gone and I do not miss them. As of my recording this, the version of the graphics API that GameMaker uses is still quite old. We still don't have access to a lot of the fancier modern tools like geometry shaders and whatnot. Although Russell K did drop a hint that we may be seeing compute shaders at some point in the foreseeable future. But there are still a lot of things that you can do to make these games run better, as I hope you've seen. So coming up next, now that I've finished this 3D optimization series, I've also been making a couple videos here and there on the different data structures in GameMaker. I'd like to finish that off. I'd like to make that my next priority. So things like maps, queues, stacks, grids, that sort of thing. There's a bunch of other 3D subjects that I'd like to cover. I'd like to talk about 3D materials, so things like normal mapping and specular mapping eventually. Deferred rendering is a subject that I've mentioned a couple times, but I've yet to actually make videos on. I'd like to do that eventually too. We'll see where we go from there. So, my name is Michael. I like wizards and dragons and making games. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. This week, I think I owe a special thank you to all the cool kids over there who have been a little bit on the patient side with me, because the last couple of weeks have been a little bit slow getting videos out, at least more so than I'd like. Otherwise, I try to post about 2 game dev videos a week, one tutorial like this, and one let's make a tower defense game. That game is coming together nicely. Hopefully it should be pretty much done by, I want to say, about October. I hope you all found that useful, and I will see you all later. Special thanks to Connor, David Key, Edward Holt, Emily Koyo, Halo Factory, Posho, Syndra Larson, Tusk, and Zenith for supporting these videos. If you want to see your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page down in the video description to join the fun.